Okay, Algebra 2, we are doing section 3.4. After the linear programming, we're going to come back and continue to solve systems of equations. But this time we're going to solve systems of equations in 3 variables. So you're still going to use the substitution and elimination concepts that you used when you were solving for 2 variables in section 3.2. But we are going to be using 3 variables. All right, so a linear equation in 3 equations, a linear equation in 3 variables is written ax plus by plus cz equals d. So x, y, and z are your variables, so they cannot all be 0. So graphing this is a little bit tough. So if you want to look at the graph, you can use this hyperlink. This is kind of a neat hyperlink. You can pull it and stretch it and turn it so you can see all 3 dimensions. But you could also look in your book for the graph of a 3-variable linear equation. All right, when solving a system of linear equations with 3 variables, you have 3 possibilities for solutions, just as you did before. So when you get one solution, you get an ordered triple this time, x, y, z. You can also get infinitely many solutions or no solution. So again, there is a hyperlink here at the bottom that you can look at to see those graphs and what those graphs in 3 dimensions look like, or you can simply look in your textbook for those graphs. All right, we are going to start with an example, and I'm on my machine tonight, so the pen is a little bit different to write with. It's going to look a little messy at first until I get used to writing. So I am going to move my writing utensil, and we're going to try to be as neat as possible. But we're going to look at these 2 equations first. So this is 3 variables with 3 equations, and you can solve for 3 variables when you have 3 equations by substitution or elimination. But you're going to look at 2 at a time. So the first one here I'm going to look at is the top one and the second one. I'm going to look for a variable that I can eliminate easily. So when looking through that, I can see that I can eliminate the variable x by simply multiplying this bottom one by -2. So I'm going to try to write that down, -2. And I didn't write that very well. Again, it's taking me a little bit time to get used to this system. That's a -2. All right, so what we're going to do then is we are going to move this equation over and we're going to rewrite it. We're going to just simply write 4x plus 2y plus 3z is equal to 1. And when I rewrite this one, we're going to go ahead and multiply it by that -2 that's out there in the front. And I know that's hard to see. You might want to make certain that you are pausing this podcast whenever you need to follow along, because it might get kind of sloppy and you need to be able to read your work better than you can read mine. Okay? So when I multiply there, I get -4x plus 6y minus 10z is equal to positive 28. So when I add these 2 together, it's going to eliminate that x variable. So I get 8y minus 7z is equal to 29. All right, now I chose x to eliminate not only because it was easy to eliminate there, but it was also easy to eliminate in the next 2 equations. So I got to find my pointer again. This is the hardest part with this system that I have on my machine. But these 2 we can eliminate the x also. We want to eliminate the same variable both times that we do this so that we end up with only 2 variables left. So this time, instead of multiplying this middle one by the negative 2. Cross this out. I want to multiply it by negative 3. Whoops, sorry about that. Somewhere. I don't think it wants to do it. There it goes. We're going to multiply this one by negative 3. So I'm going to save a little space, and I'm just going to take this and I'm going to put it, oh my goodness, down here when I multiply it. So negative 3 times 2 is negative 6x plus negative 3 times negative 3. Yuck. Hold on. Try again. There we go. 9y minus 15z is equal to positive 42. And I put it right here because now I can go ahead and add these without having to recopy this bottom one, since I'm really not very good at writing on this new system yet. But those two 6x's and negative 6x is going to drop out or eliminate the x, and we are left with 8y minus 11z is equal to 41. Now you can see that, whoops, we're going to change our color again so you guys can try to follow me along. But again, if you need to pause it to make sure that you're with me, go ahead and pause it and get what I have written down so far, because it's going to get crazy. All right, so I'm going to try to find where I'm at. Look at this equation. Oh, there. Okay, let's see. We are going to try to find. Sorry guys, this system is a little bit crazy. Alright, here we go. This one and this one both have y's and z's in them. So I'm going to take this equation and I'm going to multiply it by negative 1 and move it over so that I can eliminate my y's now. So I did negative 8y plus 11z is equal to negative 41. So the 8y and negative 8y cancel, and I have 4z is equal to negative 12. So then z is equal to negative 3, and we have one of our 3 solutions. Okay, so now I'm going to change colors again so that hopefully, again, trying to make this as easy for you to follow along as possible by changing colors. Sorry about that. So we'll go to purple. Okay, now the problem when we change colors is that I can never find my mouse again. Alright, so we're going to take this negative 3 and we are going to plug it in right here. Okay, so we're going to use the substitution, and we're going to do, I went way off the screen, 8y minus 11 times negative 3 is equal to 41. So I have 8y plus 33 is equal to 41. So I subtract 33 from both sides, and 8y is equal to 8. So y is equal to 1. And now I have 2 variables solved for. So we'll change colors again. We might be running out of colors that you can see very easily. Let's see, what can we choose? Hate to get too bright because sometimes you don't see those very well. We'll do a maroon color. Alright, so now I'm going to find my mouse. There it is. And I'm going to use this top equation up here. And I'm going to plug in both the y, and the z that I've already solved for. So I have 4x plus, oh, that was really low. That's okay. It's a plus 2, y is 1 now, plus 3, z was negative 3, equals 1. All right, now even though that plus is kind of in the wrong spot, we know what it's supposed to be, right? Because you're listening to me and not just copying down. Where is my, here it is. So I have 4x plus 2 plus negative 9 is equal to 1. So 4x minus 7 is equal to 1. So I'm going to add 7. And even though this is really sloppy, I hope you're listening to me and not just copying. 4x is equal to 8. So x is equal to 2. And finally, my answer then, and we're going to go back to basic black. My final answer is x, which was 2, comma y, which was 1, and z, which was negative 3. And after all of that work, I have solved that problem. Okay, so they take a lot of work. It is a lot of paper. And hopefully you are highlighting or changing colors like I am to be able to get to understand it. All right, so we've got another example here. Okay, example 2. And we got to look at it carefully to decide, all right, which of these equations do I want to eliminate? Which of these variables is going to be the best to eliminate? I think I'm going to try to eliminate the y's because the y's look like I can multiply fairly easily to do that. So I'm going to take the first 2 equations and I'm going to multiply the top by negative 4. So when I do that, I get negative 4x minus 4y minus 4z is equal to negative 12. I almost wrote 3 there again, but don't forget that you got to multiply both sides of the equation. All right, let's find my mouse again. And we're going to move this one straight over. I don't need to multiply by anything. 4x plus 4y plus 4z is equal to 7. And when I do that, something strange happens. That cancels, that cancels, that cancels. So on this side I have 0, and on this side I have negative 5. Well, I don't have a variable anymore. And is this a true statement or a false statement? Well, it's a false statement. Right, my pretty handwriting. There we go. And so if it's a false statement, then just like before, the answer is no solution. Okay? So this can occur right when you first start, like it did for me. It can occur halfway through after you've already done some work. Okay? But when you come up with a false statement and all your variables have disappeared, your answer then is no solution, whether you're working with 2 variables or 3 variables. All right, so let's go on to the next example. Maybe. There we go. All right, so we are going to go ahead and I'm going to work with these 2 first. I don't know why in the world that did that, but we're going to ignore it. Okay, and I'm just going to rewrite them over here so that I can work with them better because that third equation is in the way. But you can see that these are already set up for Z to be eliminated without any work. So I'm going to move this one over too. Sorry. There we go. Plus Y minus Z is equal to 4. I don't want that. Please don't go there. There we go. All right. So when I do this, I have x plus x equals 2x. Be careful. Those don't eliminate because remember we're adding them. Plus y is 2y. Now the z's do eliminate, equals 8. Okay? So then I'm going to change colors so we can watch the next two equations. Whoops. Alright, so I think I have maybe figured this out. Maybe. Alright, so these two are the ones I'm going to eliminate, and you can see that the z's are already ready to eliminate. So I'm just going to go ahead and draw my line. That way I can take up less paper. And x plus 3x is 4x. Remember we're adding. Plus y plus 3y is 4y. My z's drop out. So then I have equals 16. All right, so now I have two variables with two equations again. So I changed colors, and I think I figured out how to make my pointer be where I want it to start after all this podcast. Very good. All right, so these two have two variables, x and a y. So I'm going to take and, where did I go? And I'm going to take this one and multiply it by -2 to eliminate the x variables. So I have -4x minus 4y is equal to -16. And when we're careful, we see that this drops out and this drops out. So I have 0 on this side equals this one drops out. So I have 0 on this side. Okay, so now this is a true statement. Unlike the last example, this one's a true statement. So hopefully you remember from the same, or from the two variable, two equation ones, that this one is either infinite many solutions. Ooh, sorry. Hard to write. Or all real numbers. Okay, so these are the basic problems. You might want to go back and repeat example number 1 because that's the type of problem that you'll see most often. But example 2 and example 3 do exist, so we need to pay attention to that. All right, the next slide is a word problem. Now, I'm very well aware that there is no way that I can write everything I need to write on this slide, so I have a second slide that's a blank slide that I'm going to continue my work on. So go ahead and copy this problem down. Okay, you'll probably need to pause it, and then make sure that you're pausing and keeping up with me, because I will move to the next slide where there is just a blank screen. So we're going to continue on that blank screen. All right, so let's go ahead and read this. The marketing department of a company has a budget of $30,000 for advertising. A television ad costs $1,000, a radio ad costs $200, and a newspaper ad costs $500. The department wants to run 60 ads per month and have as many radio ads as television and newspapers combined. That's kind of worded funny. That might be a little typo thing. Anyway, you guys understand. How many of each type of ad should the department run each month? So we have to write our variables. So we're going to start with T is for television ads. I don't know why that did that. I apologize. Okay, television ads. And then the next is radio. So we'll have R. is equal to radio ads. And then newspaper. So we use an N for newspaper ads. And if you guys don't mind, I'm going to go ahead and abbreviate it because my pen is being strange. All right, so we're going to start with that money, okay? We know that if we add it all together, it needs to have a budget of $30,000. So we are going to start way over here so I have plenty of room. And we know that 1,000 times the TV ads plus 200 times the radio ads plus 500 times the newspaper ads needs to be $30,000. If you want, you can put a little comment in there. $30,000. All right, that's the first equation. The next equation says it wants to run 60 ads per month. So we're going to go over and we're going to write a new one. Okay, so we want all of them to add up to be 60 a month. So we're going to do television plus radio plus newspaper needs to be 60 ads. All right, the last one says that it has to have as many radio ads as television and newspapers combined. So that means that your radio needs to be the same as your television and your newspaper combined. Okay, so we have three variables, three equations of which we can solve for all three of those. So I'm going to change colors. I know this is strange to watch this happen. You guys are used to the other type. All right, so we are going to do the first two together. So let me get my mouse right. Okay. So we're going to do these two, and I'm going to eliminate the R. So I'm going to multiply this equation by negative 200. Okay. So we're just going to move this one over. I'm going to have to write really small. I may put it down here. Okay, so I'm going to write 1,000 T plus, I'm just rewriting it, 200 R, so I have room to work, plus 500 N is equal to 30,000. And then when I multiply by that negative 200, I get negative 200T minus 200R minus 200N is equal to, make sure you multiply this also, and you get negative, oh dear, I lost where I was. Try to find the mouse again. Okay, found my mouse. Negative 1,200. Alright, so we're eliminating the R. So I get 800T plus 300N is equal to 18,000. Okay? Alright, so now I am going to take that and I did it kind of backwards. That's okay. It's okay. We'll figure it out. All right. So I did it backwards than my way that I did it in the Now I've got myself all confused. Sorry. I did it differently than I did it in my notes, but that's okay because we're going to go back and we are going to use these two. Okay, but this time it's set up for substitution. So I'm going to take this and I'm going to plug this in for r. Okay? So when that happens, I end up with t plus n plus n equals 60. So this piece right here was what the r was, okay, but I replaced it, or I substituted it. All right, so now I have 2t plus 2n equals 60. And now these two equations both have n's and t's, two variables, two equations, and I'm ready to go back to section 3.2 where I learned how to do this. So on the next screen, I'm going to multiply this equation down here by negative 400 to get rid of the t. So I'm going to switch screens right now, so if you don't have some of this, then go ahead and pause, because I'm moving on. All right, so here's my blank screen that I need to work on so I can keep working with that. When I multiplied that equation by negative 400, I ended up with negative 800 t plus negative 800 n is equal to negative 24,000. Eek. Okay, and then the other equation that I was working with was, let me find my mouse again, sorry. $800 t plus 300 n is equal to 18,000. All right, so these are going to cancel, and I get negative 500 n is equal to 6,000. Whoops, negative 6,000. Divide by negative 500. So n is equal to 12, which was the newspaper ads. Okay, so we have solved for one of the variables. It's taken us a long time, but we have been successful. Okay, now you want to plug it back in to one of the equations that just has two variables. So I'm going to change colors so it's a little easier to read, perhaps. All right, and so I'm going to take this 12 and I'm going to place it into this equation. So I get 800 t plus 300 times 12 equals 18,000. So I have 800 t plus 3,600 equals 1,000, or excuse me, 18,000. So 800 t is equal to, I'm going away from my notes, so I'm going to go ahead and pull out my calculator here. $14,000. Sorry, I keep doing that. 400. And then we're going to divide by 800. And t is equal to 18. So there are 18 television ads. Now remember the really easy equation that we had back at the beginning, which I'll have to look back at my notes too because I don't have it on my screen, was that R was equal to T plus N. So let's go ahead and plug those two things in. This one goes here, and this one goes here. So we have 18 plus 12. So R equals 30. And if you can mental math that actually works because it needed to be a total of 60, and it worked, and then of course this one worked. So this is a word problem, so we need to finish with a word answer. So it would be the company. You guys might want to just listen. The company runs 18 TV ads. Okay, this is really messy. 12 newspaper ads. Whoops, not that kind of ad. Newspaper ad. There we go. And 30 radio ads. So pardon the messiness there. It is the way that the little tablet in my classroom is working. All right, so we are going to go to the next slide, which I believe is your turn. Very good. So copy this one down. This is for you to practice and bring your answer to class next time. Again, this one is going to be more like example number 1. So if you need to replay example number 1, that would be great. Okay. All right, here are the references, and we hope that you guys got all of this down, and we will see you in class.